G'day. Today's video is a little bit different. A number of you commented on this thing a while back, and so today I've got the drawings for this, and I show you how to make up this, but also one of these. The difference here is, though, I've already got one of these, and so I don't need another one. So, and also it was stinkingly hot in the shed yesterday when I was trying to do this. Got up to 41, I believe, which is rather hot in a tin roof shed, not all that pleasant. So instead it's done as a series of PowerPoint slides and with narration, and so we progress through how to make one up.
Before you start making your collet block, you'll need basically a test bar, a bit of ground or bright finish material, accurate centers in each end, probably around about 20 millimeters in diameter, about 300 long, and what you'll do is you'll put the half manufactured collet block on that, and then use that as to make sure that the flats on the collet block are actually accurate to the axis of the material going through the collet. You can also use these things for setting up the tailstocks of lathes, or dividing heads on milling machines and getting the tailstocks lined up on those too. So a useful thing to have. I've got a purchased one which has got a Morse taper on the end, but a standard bit of bar is plenty good enough for most things. You can make up an ER collet nut. I've done so before. They're a little bit fiddly, but not too awful. But it's probably easy to buy them off places like eBay or an equipment supplier. You'll also need a wrench or a spanner to be able to tighten the thing up. Either a C-wrench type arrangement, or you can get anti-slip type wrenches too on eBay, not terribly expensive. To start with, turn your blank to the appropriate size. The measurements or the dimensions I've given on the slide there are for the peak-to-peak dimensions for the AF measurement. If you want to go slightly bigger, you can. Doesn't matter too much, and you will want an accurate center in the end of that bar too. Next, turn one end down to the thread major diameter. Add a relief groove or a run-out groove to the end of that reduced diameter, and you can put a chamfer on the front too for the thread. Then cut your thread. Both threads are 1.5 pitch, but I'd check your nut, because sometimes the nuts have got an odd thread in them if they're a special sort of ER nut. Bore your through hole. The sizes I've given on the slide here are from a RegioFix brochure I've got all about ER collets. You can be a little bit bigger than that. It doesn't really matter too much. It's just if you go any smaller than that, you could run into strife. And if you use oversized collets like I do, then you might want to make it a bit bigger. Then you need to cut the 8-degree cone. The sizes I've given there are maximums. If you go any bigger than that, you may have trouble with the collet closing up properly at full squash. So just watch that one. I think my cone is just slightly smaller than that, so you can play with that a little bit and see how you go. Now we get to the tricky part. The collet block is basically finished, except that it's round rather than a hexagon. And so what we're going to do is, using the test bar that you bought or you made with the collet and the nut, and clamp that test bar onto the block. But what you're also going to do is make up a spacer. ID is the test bar diameter. The OD is the diameter you bored the inside hole, and you want to get that as good a fit as you can. But what that means is, when you start machining the flats on the collet block, the back end won't sort of deflect and give you a wonky sort of cone. It's going to keep everything sort of basically parallel. Here's another drawing of the assembly, and so you can see the spacer sitting in there. Also worth noting the collet there. I've drawn a 2019 collet there, and it's a 20 bar, so it's sitting right out. But you can imagine that if this was, say, a 2120 collet, then the nut will be further on the thread, and that's why you don't want that diameter too big, because otherwise you run out of room for that collet to crush down. Now there are two ways of doing this. If you've got a dividing head or a rotary table that can act as a dividing head, I'd suggest the easiest way is to set up the collet and test bar assembly in the dividing head, and then just cut the flats going round. Then put another one on, and do that again until they're all done, and basically you've then got a collet block. However, if you haven't got a dividing head, there is another way. What you need to do to start with is put a flat on the collet block, and then turn it over and put a flat on the opposite side, making sure that both of those are equidistant from the axis of the collet block. Then what you need to do is put the assembly with the test bar in a couple of V-blocks, and using a 60-degree square, just align it all and clamp that down. The position of the V-blocks isn't critical. I mean, it's nice to have them as close as you can to the actual block being machined, but I'm meaning that they don't. The positioning on the mill table isn't critical, because you're putting a flat surface on there, and so you're going to mill where you can. But you do that, and then repeat that a few times. These are the dimensions of my hex collet block, and as you can see, I've got the bore just a little bit bigger, and I've got the largest diameter of the cone just a little bit smaller than the recommended numbers that I put on the slides. But other than that, it's a pretty straightforward turning project. The chamfers on the ends of the hex section are a 30-degree chamfer, just pretty standard. Imagine it's a long nut. Here's the bit you've been hanging out for. These are the dimensions of my collet block holder. The length is 100 millimeters. That doesn't matter too much. It basically matches the collet block. So if you've got a longer or shorter collet block, you can certainly change that if you like. The counterboard hole that you can see in the section there, the diameter 22 is just chosen because that's the size of the socket I have that goes on the 3/8 UNC bolt that I use to hold this down. The other threads are 3/8 UNC, just because it fits my clamping kit, and so all the threads are the same. I can do all sorts of things that way. Other than that, I'm using M6 for any keys that might go in there, but you can use whatever you like, really. If you're not a key person, you can leave the keys off even. It doesn't matter too much. These are the dimensions for putting the 12-point profile on the interior bit. Once again, I'm using a 30-60-degree square, but at 100 millimeters long. What you can do is just grab this in your vise. If you've got a 4-inch vise, 100 millimeter vise, using the square to kick it up at the right angle, and then just machine the flats in there. You'll need to work out how to find that corner, but that shouldn't be too difficult. The more accurate you can be, the better off you are. But really, if you're a little bit lower, provided you've got a snug fit for the hex on your collet block, it doesn't really matter too much. Just to complete things, these are the dimensions of the stop plate on my collet block holder. The holes are 10 mil, so you can have the 3/8 bolt going through. Pretty straightforward. The only thing to note there is that should we say, middle hole is 11.5 from the edge rather than 10 from the edge, and that's just to help clear the when it's bolted down with those two holes, help the bump clear the stock. If you're using large stock, you may even have to relieve that a little with a file, but yeah, other than that, it's all good.
So there you go. Thanks for watching. See you for the next one.